Welcome everyone, and thank you for joining us today for our joint Sandalwood and Visual Decisions webinar on Industry 4.0 Lessons Learned. In our last webinar, we talked a lot about how you can create a data-driven manufacturing culture, and in doing this, will have an enormous impact on your company and the success of your Industry 4.0 initiatives. You can find the replay of that webinar on both the Sandalwood website and the Visual Decisions website. In our webinar today, we are sharing our joint expertise, best practices, success stories, and lessons learned from our Industry 4.0 implementations. You'll hear our team of experts talk about getting started with Industry 4.0, the Industrial Internet of Things, systems integration and cybersecurity, and also AR, VR, and simulation. And if you have any questions as we proceed, please paste them into the Q&A or the chat, and we will try to answer them. So let's get right to it, where our first expert, Malika Wadhaben, will talk a little about how to start your Industry 4.0 journey with current state and process mapping. Malika?
Awesome. Thank you so much, Ree. Well, good morning, everyone. Really excited to talk to you today about getting started with Industry 4.0. As mentioned, my name is Malika Wadhaben. I'm a team lead with the Systems Engineering Department at Sandalwood Engineering and Ergonomics. I specialize in the areas of digital engineering as well as business process development and re-engineering. And I've been supporting clients now for a few years by helping them to identify opportunities for digitization and Industry 4.0 through the means of business process mapping. So what I'll do today is talk to you a little bit about what we've seen clients do as they try to get started with Industry 4.0 and any lessons learned along the way. So to get started here, it's important to keep in mind that moving your business forward with Industry 4.0 really is a journey and not a destination. Because our Industry 4.0 solutions are so comprehensive, so interlinked, you really need to have both a strategic and staged approach. And there are a lot of reasons for this, but what we've seen with our clients is that by having a strategic and staged approach, what you're going to do is help build confidence and trust in the process owners and management alike. And that's really important because Industry 4.0 technologies really change the culture and the way that people are doing their work. So it's important that you keep those things in mind. Now, successful Industry 4.0 implementation does require thoughtful planning. And while it sounds like it should go without saying, it's important to keep in mind that with that thoughtful planning, we're not just talking about the implementation of the Industry 4.0 technologies, but more so why you're implementing and what the business value is from those implementations. Really, at the end of the day, your goal is to accelerate and optimize your operational gains. So it's important to leverage these technologies as a lever for maximizing your benefits. So knowing that you need to have a strategic and staged approach, knowing that you need to be very thoughtful about what the business benefits are, where should you start in order to propel your company forward with Industry 4.0? So if you go to the next slide, Ree, really where we recommend you get started is understanding the current state. Now, understanding your current state is really your baseline. It's where you're going to be able to do analysis to really help dictate where your future state should be. You don't know where you're going to go until you know where you're starting from. So keep that in mind as you start thinking through, well, what's right for me? So in order to start by looking at your current state, what we recommend is process mapping. So for those of you who are a little less familiar with process mapping, that is the visual display of steps, actions, and operations that constitute a process. So what we've learned through going through process mapping with a lot of our clients is that there are a lot of different types of value that come from process mapping. First and foremost, it increases your understanding of a process. And while it seems really simple, you put down your process on a piece of paper, what we're finding is that a lot of people have different perceptions of what the process is. And so by allowing all of us to look at the same piece of data, it allows for some of these things that we've listed below. First and foremost, you're going to be able to have easier identification of gaps and waste in your process. You're also going to be able to identify process improvement opportunities. So I guess to linger on these two a little bit, with our clients, we've seen just really quick wins when it comes to mapping. So with gaps or waste in the process, there are a lot of examples I can think of that have been beneficial for the organizations we've worked with. And I remember, speaking of one specifically, we worked with a company that was quite large, and I don't think that they really understood what was going on in the different departments. So if we go down to the last one here, greater cross-functional awareness was huge for them as they looked at all these process maps and said, wow, we're all trying to get the same piece of data into our department's work streams. Why are we all doing that in separate ways? Why aren't we doing this as a group? Why aren't we collaborating and understanding where our single source of truth is, if you will? So just by taking a look at the current state, that was just some of the quick wins that they were able to get just to see, you know, what is going on. So like I said, these are just a couple. Another one here is developing metrics. I think by understanding your current state, what we found is that some companies didn't realize they needed to put metrics against certain things to measure success of how efficient processes were. So that was also another quick win and another value of doing these process maps. So if you go to the next slide, Reed. Now that you kind of understand a little bit about what the value is at a very high level for process mapping, what makes for successful process mapping? So first and foremost with our clients, what we've learned is that a clear project scope is critical for ensuring that there is value in what is being done. This is a relatively large initiative that would take place, since we are saying that it does need to be cross-functional if that's what you guys are targeting. And so making sure the intent of mapping is well defined is critical. You need to say, why are you mapping? What are you mapping? Where, when, why? All those good questions really need to be identified as you start this initiative. Now, also as a part of this initiative, it's really critical that you're also going to get cross-functional team involvement. As we've talked about before, Industry 4.0 is a very comprehensive and linked grouping of solutions. So having a big team take a look at this is going to help to ensure that you're going to get a solution that is comprehensive and interlinked as well. So it's also imperative that you include your stakeholders and make sure that they have alignment with what you're doing. As mentioned, since this is going to be a large shift in culture and the way that people are doing their work, you're going to want to make sure that those people are involved in your process mapping initiatives. Another thing that we've learned along the way is that successful process mapping really means you need to understand what the boundaries are for your mapping activities. Where does your process start? Where does it stop? Things of that nature are really critical just to ensure alignment and that this is going to be value add as mentioned. And last but not least, the one thing we've also learned throughout this is that you need to choose the right type of process mapping. Now, process mapping as a concept seems quite simple. You're just putting it on a piece of paper, what you're doing. However, there's a lot of different types of process maps and a lot of different standards out there. And so on the right here, you can see just 4 of those listed out: value stream mapping, swim lane mapping, flowcharts. So really making sure you've got your program or your project scoped really well, those boundary definitions defined well. All of that is going to help make sure that whatever type of mapping you're doing is going to be effective and yield the types of results you're trying to see. So those are just a couple tips on successful process mapping. And Rhea, if you go to the next slide here. So now you've kind of put forth a map. Let's say you've gone through the exercise, you've mapped everything out. Now what? So really, as I mentioned earlier, successful implementation of Industry 4.0 really has to stem from clear understanding of what you're trying to have solutions for. So identifying your pain points and gaps is a really critical part of this. So what we've got here are just a few things that we've seen be successful, just some questions that might help you move forward. All of this is really, as I mentioned, going to be dependent on the type of map you're doing, the scope of your mapping. But if you're doing value stream mapping, as an example, what are the value-added activities? Can we remove non-value-added work? For some of our clients that are doing more business re-engineering, there are a lot of questions around manual versus automation. And so we've seen them ask this question: are there areas that we could automate or digitize as an enabler for our Industry 4.0 solutions? And that has driven a lot of projects and a lot of success for some of our clients. Now, the next 2 here, systems interaction and digital tools, are also big ones that we've seen help organizations as they try to figure out which Industry 4.0 solution they should move towards. So understanding your systems interactions, how is information being passed through my system? What is that single source of data? And what kind of systems and apps are we using currently? All of that has been really critical in helping companies identify, well, where should I target and where should I go? And then the last 2 here are ones that are a little bit more production centric, but still just as critical if that's where you're targeting, bottlenecks, as well as some of these other items like supplier market issues, high downtimes. All of these are certain, depending on what you're doing, certain questions you'd want to ask to help you determine, okay, well, what do we need to do next? So if you go to the next slide, Ree. So now that you've taken a look at your current state, you've identified some pain points, some gaps in your system. Now really this is where we say, figure out which Industry 4.0 solution might work for you. So step one of doing that is documenting your ideal state. Now that you know what those pain points are, take those into consideration and say, okay, well now what do I want to do? Keep in mind, at the forefront of your mind, that you're trying to drive efficiencies and maximize those operational gains. And so mapping that out is always very helpful in a very similar fashion to your current state map. So any sort of future state mapping will just help with that communication up to your management team, as well as your peers, as you start proposing some of these Industry 4.0 solutions. Now, along the way, since we did mention this needs to be a very staged approach, it's critical that you document not just your final destination of X Industry 4.0 solution, but how you're going to get there and that journey that we talked about. So we recommend taking a look and really documenting out that short, mid, and long-term goal, as well as the plans that go along with it. This is also going to help with that culture shift, as well as making sure management is aligned with what you're trying to do and that time frame in which you're hoping to do that by. The last part here, now that you've got your ideal state, you kind of know the plan to get there, is ensuring that plan does align with your business goals and objectives. This is so critical to ensuring management buy-in. You need to make sure whatever you're doing is aligned with their high-level vision, and this has been very critical for our clients who are trying to justify some of their Industry 4.0 solutions up the chain. And last but not least, it's really important to keep in mind that success is dependent not just on that management buy-in, but their support. So I'm going to keep going back to that culture piece, that we're really changing how people are doing work. And so in order to make sure that they're bought in, your process owners and so forth, you really need to have management not just say, yes, we're good with this, but also, yes, we're going to be a part of this and help make sure that that culture of, this future is really, really solidified. So that's kind of the basis of what we've seen be successful, is just making sure you take into consideration that current state as a summary here. Make sure that your plans take into consideration and really address pain points and gaps, and that you create a plan that has management backing as well as their support. So hopefully this is just a really quick, high-level way that process mapping has been really effective in helping identify opportunities for Industry 4.0. And so with that, I'll pass it back to Ree to talk a little bit about some of these other initiatives where we've been able to support.
Thank you so much, Malika. And I guess we'll move on now to Tim and his discussion of the Industrial Internet of Things. Tim?
Thanks, Ree. Good morning. As Ree mentioned, my name is Tim Stewart, and I'm president at Visual Decisions. At Visual Decisions, we've been in business since about 2002, and our focus is to help customers combine the smart factory and the lean factory to drive improvements to cost, throughput, and quality, and other metrics. Our customers have seen really dramatic improvements, 30% increase in OEE, 50% scrap reductions, and much more. But the biggest lesson learned during that whole time is this: just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes must be adapted to take advantage of the new capabilities to drive real improvements. So fundamentally, people have to do something differently tomorrow than they do today for real change to occur. So today I'm going to be looking at some examples of implementing the Industrial Internet of Things, IIoT, and how we've worked with customers to make those Industry 4.0 solutions a part of their daily processes. I'll also talk a little bit about how to maintain ownership and engagement across the organization as you do so. Next slide. So the first thing I want to talk about is visual controls. And one quick note here is that manufacturing has really embraced technology over the past. Manufacturing has almost always done so and really looked at lasers and augmented reality and robots and cobots and so forth. And these things seemed futuristic 5, 10, 20 years ago for a lot of these different technologies. And they've really done a great job integrating this into the manufacturing process. What has been a little bit more slow to change is a lot of the continuous improvement activities and so forth, including visual controls. And so you see some examples here on the page with whiteboards, printed off Excel spreadsheets that then get put up on the board and so forth. And there's just a lot of opportunity for improvement here in terms of being able to utilize the data coming directly from the process, putting digital displays out there, and then organizing things in such a way that you actually utilize those within the process. Right now, everything is very wasteful. There's excess motion, there's rework, people typing or writing this up on the whiteboard and then somebody coming over and typing it into Excel. And at this point, these boards are really due for some automation. So visual controls provide a great opportunity to make your Industry 4.0 solutions a part of the culture. Part of the pushback that I get from lean professionals is that you'll lose engagement or ownership when people are not manually maintaining that information on the whiteboards. But if you set up your daily process so that the people are still engaging with that display and they're still interacting with the information there and they're still utilizing that information to improve the process and so forth, you'll still get that engagement, you'll still get that ownership, and you have the opportunity to really extend what they do and drive a lot of additional understanding of the process by presenting more contextual information and a broader set of data than is possible to maintain on a whiteboard. Next slide. So I come from a lean manufacturing background, and improving Kaizen is actually how I got started with Industry 4.0 in the first place. Going into different companies, I got frustrated, with where they would pick events, where they would pick to run events based on either who was shouting the loudest or just reacting to the latest downtime in the plant. And here are some ways that Industry 4.0 can be kind of embedded into your process. So first of all, you can utilize IoT, RFID, and other technologies to detect where problems are happening in the first place. You can use those same technologies to understand why the problems are occurring. So not just the fact that the machine went down, but why did the machine go down? You can expand the solution space of what's possible with these additional capabilities and so forth. You can use technologies such as simulation or digital twin or augmented reality and virtual reality to test the solutions. But then you come back in the Kaizen process to measuring and analyzing the results. And again, you're back to utilizing those IoT technologies and so forth to really understand exactly what the impact of that change has been. And then baking all of that into the standard work, as I mentioned on the last slide, to really instill those new disciplines in the culture. Now, as you're doing these things, one of the things that you want to be sure of is that you don't create new technology monuments. And what I mean by that is a monument in lean manufacturing is like you have a pole, a roof support within the factory that you have to build your process around. And what you don't want to do is put in a solution that is rigid, that can't be adapted as the process evolves. And one of the reasons that IIoT is attractive as opposed to some other solutions out there is that it is very adaptable and something where if you're utilizing agile development methodologies and so forth, you can continually evolve that solution over time so that it grows with the process. Next slide. So unlike some of the other areas that I've talked about, with root cause analysis, nobody really pushes back on why we want more data. So what I want to talk about here is when should you gather data, what data should be gathered, and so forth. And so there's a saying that the best time to plant a tree is 20 years ago, and that the next best time is right now. And it's very much the same with data that you want to collect out on the shop floor. The best time to start collecting the data is last year, so that when I have a problem, I already have the data that establishes what the baseline was before the problem, and then shows me what was going on when that problem occurred. So what that tells me is that I have to be very purposeful about my data collection, and I have to have a plan for what it is that I want to gather. And so the first thing that I have to do is decide where I want to gather the information, and I'll focus on two scenarios there. The first one is if a process is currently out of control. That's where you want to plant the tree right now, and you want to go out and you want to collect information about what it is about that process that is getting it out of control. So create your data plan around what you can collect that might be influencing that. The second thing is that if you have critical processes within your facility, either from a constraint perspective or cost or anything else, you want to be able to gather as much information about those processes as you can. Ideally, in a ideal world, data collection and storage would be free, and we just collect everything. But since there is a cost involved there, you have to be mindful about what it is that you're collecting. But really, you want to collect a superset of what you think might be impactful for those critical processes. In each of those different scenarios, you should definitely put together your data collection plan of what are the potential causal factors, what data you want to collect, where you're going to collect it from, how you're going to store that information, how you want to contextualize that data, and so forth. And then put control plans in place to monitor those factors for signals of issues, and use alerting to notify people when control limits are exceeded, and so forth. And then from a data cleansing perspective, you just want to make sure that you're continually scanning that data coming in for anomalies, whether it's sensors reporting anomalous results out of range and so forth, sensors not reporting any data, so missing things, network issues, broken sensors, etc., human input issues, and more. Next slide. And the next step is to really utilize these capabilities within your existing processes as well. So you're going to create particular analyses that you're interested in, and so forth. But if you really want to make these Industry 4.0 solutions a part of your overall process, then some of the continuous improvement processes and management processes that you have in place today, go ahead and embed these technologies within there. And I'll use value stream mapping as an example, but I've been running weekly webinars this whole quarter really on different management and lean practices that you can utilize this information within. And utilizing value stream mapping as an example here, some of the advantages of using this data within that process is that when you do value stream mapping manually, you gather everybody into the conference room and you really pick, we're going to run this value stream on this one product or this one product line. And now we spend 2 weeks gathering data, about that. Whereas if you're using systems, there's an upfront process of, getting that set up so that you can collect all the information required. But once you've done that, you have it for all of the different products, and you can, very quickly go between products and see those value streams and all the information for all the products at one time. It's far more precise and accurate than kind of saying, I think it takes about 3 days between these processes, or going out to the floor and taking a snapshot in time and how it operated that one time or that one day or that 1 week that you looked at it. It reflects the true process. So very often in value stream mapping, people will go through and kind of say how it ideally works and so forth, as opposed to all of the deviations it normally does take. You can show averages and distributions instead of just a single time. You can have it automatically update with the process. So all too often, a value stream map or an FMEA or any number of other things will be done once as a project, and then it'll go into a drawer or hang on a wall as a decoration. But if you do this with systems, it can actually be updated as the process lives on, and it will automatically be updated and be evergreen on an ongoing basis. The key thing there is that it can then be used as part of the daily process. Instead of as a project that's done once to make some particular improvement, it can be something that you utilize as part of your management process on a daily basis. And that will really deepen the understanding, ownership, and engagement of people within your lean processes. And then the focus also shifts to improvements as opposed to just collecting the raw data in the first place. Next slide. So some closing thoughts on this overall topic. And I've touched on some of these, so I'll go pretty quickly. Plus, I think my 10 minutes are just about up. But in terms of some of the pushback that I've gotten on utilizing this within the overall management process within the factory, you can actually get greater involvement with this. You just have to set up your standard work so that focus shifts from doing the grunt work of writing these things manually or retyping them into Excel, or then pulling up 14 different Excel spreadsheets and trying to analyze information across all of those, to really utilizing the data to drive improvements. From a lasting ownership point of view, as these solutions can become part of the daily management process, that's the key in order to really drive that lasting ownership. Improved understanding, make certain that you're contextualizing the information in the first place and working with your different teams and getting them involved and showing them how this information reflects the process and what can be done with it. Visualizing possibilities, the tools are just about endless in terms of what you can do to improve the process utilizing these things. And then just the investment in the change, make sure that as your people are involved with these things, and you really are driving that lasting ownership, embedding it into the daily process, building your standard work and so forth, that people are invested in actually losing the weight and not just wearing the Fitbit because it looks good on them. So with that, I'm going to turn it back to Reed.
Thank you so much, Tim. That was a great discussion on Industrial Internet of Things. And more on that topic, I'd like to hand it over to Paul for the systems integration discussion.
Hi, thanks, Ree. So I'm Paul LaGroy, the Director of Systems Integration Services at Sandalwood. Today, I'm going to be talking to you about Sandalwood's approach and experiences around system integration, which is one of the Industry 4.0 pillars. I like to think of systems integration as the process of bringing together various subcomponents to create an overarching and functional integrated system. One of Sandalwood's primary areas of focus is the integration of plant floor manufacturing systems. The ability to integrate a variety of devices and systems using different methods and infrastructures is critical to the success of your Industry 4.0 initiatives. Over the next few minutes, I'll be touching on various aspects of a typical integration project, including the data acquisition, data visualization, system optimization, as well as system security. I'll explain the different considerations and approach we take as part of our integration efforts at Sandalwood. As you start defining the goals of your system, you're going to be asking yourself, what data do I need and how am I going to get it? Traditionally, most of the information for your manufacturing systems came from your plant floor PLCs and controllers. This is still the case, but with technology getting better every day, there are increasingly more options available for your consideration. For example, there are many different types of smart connected sensors now available, as well as cameras and smart cameras, existing and custom APIs to connect to other existing systems, as well as interfaces allowing for human input where it makes sense. It is important to know and evaluate your options so you can choose the most effective means of obtaining your data. You must also consider how you are going to collect data from these devices and systems. Again, in most cases, this has traditionally been OPC data flow from the PLC up to data collectors, eventually passing info through to your application server. Over the past several years, we're seeing increased use of the MQTT standard for these IIoT systems, as well as other modern approaches around the use of edge devices or sending data direct from plant floor device to cloud application. It's a disruptive time. Some of the limitations you may have faced in the past may not be as prominent with some of these new technologies. It's important to balance these new capabilities with your legacy realities and come out the other end with the most effective solution for your needs. And from a systems integration standpoint, it often requires a mixture of many of these things I've just discussed. Next slide, please, Ray. The second piece of the puzzle I'll be discussing here is the data visualization component. So now that you've got the data, what considerations are there in making it available to users? As I mentioned briefly while discussing data acquisition strategy, the first step in designing your system is identifying your end goals. You can't develop a path forward until you know where you want to end up. This may begin by identifying and agreeing to your critical KPIs. Who needs to see the information? How do they need to see it? How fast do they need it? It's very important to take the time to map out this type of information. It will help tremendously when evaluating and selecting software options. There are literally hundreds of software packages, each with their own flavor or niche, but I'm willing to bet that in almost all cases, the hard part will not be finding a software that will do what you need, at least most of what you need. The harder part will be deciding between various competing products. Many of the software packages are very flexible. We'll often have customers who are tempted to develop their own application because an off-the-shelf offering doesn't do exactly what they want. Each manufacturer is unique in one way or another, but I would ask the question, are you that much different than everybody else? One-off applications are expensive to build and expensive to maintain. In almost all cases, I would suggest an existing product is the way to go. And even once you've selected a software package, keep in mind that many of the platforms have a marketplace with existing modules that can save a lot of time, effort, and investment in configuration and can really accelerate your progress. If someone has already done the work, there may be no need to reinvent the wheel. Another strong recommendation is standardization. If you can develop standards around your data collection, dashboarding, and reporting, you can make your life a lot easier when it's time to replicate your efforts to additional machines, lines, or plants. Taking a little time up front to develop the standards can save enormous effort further down the road, including around system maintenance. And as you focus on the visualization of your data, it's critical that you ensure what you're displaying is accurate. I think people tend to underestimate the time and effort that goes into ensuring the data is accurate. But if this isn't done properly, the system can become pointless, or worse, it can actively point you towards problems that may not exist. Avoid garbage in, garbage out scenarios and make sure you're taking the time to prove out your data. The last point I want to make on this slide is around system consolidation. As you develop your systems, look for ways to consolidate your various functional systems around one portal. Everyone hates going to one place for their quality information, another system for their machine monitoring, and another system yet for maintenance. The more you can get away from these chimneyed structures to a truly integrated system, the better off you'll be for a wide variety of reasons, including just basic user acceptance of the systems, which is critical. The primary purpose of many of the IIoT platforms is to be that central portal. Is to be that central portal for all your system data, so you don't necessarily need to replace those existing systems. And in many cases, you can just use a modern IIoT platform as your wrapper around them. Next slide, please, Ray. As your system evolves, you'll move from just collecting data and displaying your critical data to asking yourself, what else can I be doing to optimize my system? I would say the first step is ensuring the data from your system is actionable. It's one thing to show a bunch of numbers on a screen, but if the users can't easily decipher what is important, then you're not providing the information they need. Is the screen optimized to highlight what's most important? If the user needs to react, is the screen laid out in the best format to support those activities? Do you have rules in place so that the system can automatically alert a user when they need to take action? Are you giving them the information where and when they need it? Are there other means of providing the information that could be helpful, such as on board, supervisor tablets, etc.? System optimization is all about getting the right information to the right people at the right time. Additionally, it's important you're maximizing the use of your data. Data is everything in the modern world. Is anyone tasked with reviewing and evaluating your historical data, or does it just sit there collecting digital dust? Do you have data science expertise on staff to identify those patterns and opportunities? Many of the IoT platforms have modules available to help with analytics or SPC, or means to feed data up to your higher level BI systems for further analysis. Continuing along that path, you'll start wondering to yourself, instead of looking in the rearview mirror to analyze what already happened, how do I use my system to prevent downtime or other negative occurrences in the future? This is the natural evolution from a reactive process to a more predictive, forward-looking model. This is an area where we're seeing a lot of increased interest from our customers. Again, a lot of the existing software platforms have built-in tools to help develop predictive models with alerting capabilities, so you can try and head off disasters before they happen. This continues into machine learning and AI, where your system is teaching itself and potentially taking action without the need for human intervention in certain cases. This, of course, is all about your comfort level and the rules inherent in the system. But just as some cars can drive themselves now, these systems will become more and more self-reliant over time. Lastly, as you're nearing the end of your evolution, it's important to realize that you are never really done. You need that constant feedback loop. Is the system still giving you what you need? What else can you be doing? How can we make it better, smarter, faster, etc.? The reality is that the speed of change is just increasing. And although I'm sure at times we all wish we could just take a breath to remain competitive, none of us really have that luxury. Next slide, please, Ray. As a final consideration, I'll note that as manufacturing facilities get more and more connected, it's incredibly important to ensure the security of these systems and your manufacturing environment in general. I'd like to pass it over to my colleague, Kevin Black, who will be talking to you today about manufacturing cybersecurity.
Thank you, Paul. My name is Kevin Black. I am a cybersecurity engineer who's part of the systems integration team at Sandalwood Engineering and Ergonomics. Today, I'll be talking to you about manufacturing cybersecurity. As manufacturing facilities become increasingly connected to the outside world, plant floor devices need to be protected as well. Most legacy systems on the plant floor do not have adequate protection, as many of them are running older operating systems like Windows XP, Windows 7, or even Windows NT. When building a manufacturing cybersecurity plan, it is essential to include a number of key features. Today, we'll be discussing some of these features, but by no means all of them. We'll be looking at asset inventory, network monitoring, an anti-malware strategy, patching implementation, access control, data classification, and a removable media strategy. Next slide, please. It may seem odd, but having an asset inventory is one of the most key parts to a manufacturing cybersecurity strategy. It is impossible to protect devices that you don't know exist in your plant. Asset inventory, then, is often made up of Excel spreadsheets containing information about devices in different areas of the plant. However, as a business grows and more locations are needed, these Excel spreadsheets can become unmanageable. As a result, using a centralized asset inventory solution can greatly improve data retention, as well as provide a means to ensure that data inputs are accurate and consistent across facilities, and provide reasonable reporting methods to management. In addition, it's a lot quicker to use an automated scanning tool to gather inventory rather than walking around a facility, keeping notes, and then later uploading them to an Excel sheet or centralized system. There's a number of unique and useful automated tools available now, including Cisco Industrial Network Director, What's Up Gold, and a number of other options. Next slide, please. Network monitoring is essential in order to know if there's any traffic on the network that is unexpected, or even if there's any known malware being seen across the network. Logging can include standard sources from devices such as routers, switches, and even Windows or Linux operating systems. These can send system logs or syslogs, and some Cisco devices can also send Cisco net flows. These logs can be reviewed and aggregated, and it's possible to identify traffic that is going external from the network or traffic that is unexpected and try to accommodate remediation for this traffic. However, these logs are mainly useful from a forensic standpoint and are unable to identify things in real time. Nowadays, there are network monitoring systems that either passively or actively monitor the network. The difference here is that a passive system sits back and listens to the traffic, similar to deep packet inspection with Wireshark, and can alert when things go outside of a baseline. This baseline can be set over a period of time to identify standard traffic across the network. Active monitoring can go out and scan the actual network looking for traffic that could contain malware or could contain other types of viruses. Next slide, please. An anti-malware protection strategy is key in order to prevent unknown software from running on the actual endpoints of the devices. This is different from monitoring, which watches just the network, as the anti-malware protection strategy will focus on the actual device. When determining what anti-malware strategy to use on the plant floor, it's essential to know the difference between application control whitelisting and continuous monitoring. Continuous monitoring includes standard applications that people are used to on their laptops, like McAfee or Norton Symantec endpoint protection. However, these continuous monitoring scanners can use a lot of system resources on the device. Application control whitelisting is intended to be a much lower usage of the device resources while still providing protection. The whitelist is created by building a list of applications that currently reside on the device and noting that those are allowed to run. Anything that is not on that list is then prevented from running. This can provide a significantly reduced footprint as opposed to the continuous monitoring. However, when choosing a whitelisting solution, it's essential to think about the ease of configuration of that solution. Many of the solutions include automated scanners that go out and gather the applications and add them to the whitelist, but there are several that require manual input. Next slide, please. Patching is essential, as there are actually websites out there now that include lists of known vulnerabilities to operating systems and devices and even applications. Keeping up to date with the firmware patching level of applications and hardware is essential to prevent yourself from being vulnerable to these known access points. Windows patches are also very important, as the Windows operating system has a number of easy vulnerabilities that can be taken advantage of if it is left unpatched. Two such cases are the remote desktop protocol and the WannaCry virus. Some time ago, Windows identified a remote code execution opportunity in the remote desktop protocol and released a patch for all operating systems going all the way back to Windows XP. In addition, the WannaCry ransomware was used to hit a number of different manufacturing and other industries. Windows also released a patch for this. However, when deciding whether or not to patch on the plant floor, it's essential to weigh the potential impact, if left unpatched, against the amount of downtime that will be created on the plant floor during patching. These two systems, or these two vulnerabilities, are at such great risk that we would always recommend patching for them. Additionally, as Wi-Fi enabled devices become more prevalent on the plant floor, these must be patched as well and cause increased risk to the environment. Next slide, please. Do you know who is accessing your devices and why and what they're doing? That is the essential piece of access control. Many places do not know who's using their devices when or why, or for what purpose, as many plant floor devices use a single login where everyone in the facility knows the password. It is essential to take a least privileges standpoint when creating access control to ensure that people who don't need access to the device do not have it. In addition, access control should include a means to have a timeline to see who was accessing the device, when, and what they were doing. In addition, it's essential to remove individuals who have left their current role, moved to a different facility, or left the company so that they don't continue to have access to devices where they don't need it. In addition, access control can provide password policies and controls to ensure that password length is met, there's a sufficient number of different types of characters in the password, and the password is changed at a set frequency. Lastly, there are a number of different password repositories available, including Beyond Trust, OneTrust, and CyberArk. These provide a cloud-based means to store passwords and only access them when they are needed. Next slide, please. It is also very important to be aware of what types of data are accessible on the plant floor. Most of all, you must be aware of personal identifiable information. This can include things like an IP address, a bank routing number, social security number, or even an email address. We must be purposeful in what we're collecting on the plant floor and know what is being collected, what the risks for that data are, and what levels of protection are necessary to keep the data safe. In many cases, some applications on the plant floor might use an email address as a contact information, or phone number, or even a badge number to access it. It's essential to know that these are being collected and know how to protect them. Next slide, please. Lastly, a removable media strategy is incredibly important on the plant floor. There are known cases where removable media has been used as an attack vector to shut down production facilities. The area around a facility can be seeded with a virus and just wait for somebody to plug in a USB device at home, obtain the virus unknowingly, and then plug it in at work. This has been used to shut down facilities throughout the world. To protect from removable media, there's several different methods, including hardware means by using physical USB port locks to prevent the use of USB ports, or by placing devices with USB ports in locked cabinets. There are also various software means to prevent removable media unauthorized access, including ensuring that all devices are scanned regularly, or using various tools within the Windows operating system, such as Registry Editor or Group Policy Editor, to prevent USBs from being used. Now I will pass it back over to Ree.
Thank you so much, Kevin. And I'd like to ask Pam to give us a brief discussion on AR, VR, and simulation.
Thanks, Ree. Hi, everyone. So my name is Pam Dwyer, and I'm a manager here at Sandalwood Engineering and Ergonomics. And I'm going to talk about a couple of use cases and lessons that we've learned around augmented reality, virtual reality, and then simulation as well. And when it comes to these three things, primarily AR and VR, you know, the big question from people is, this is great technology, but how can I actually use it or apply it in my organization? And I mean, it's a simple question, but it's a great question. And I think the answer to that is really still evolving. And obviously it's applicable to your specific circumstance, but these are a few good applications that, that we've worked with, and hopefully you can take some lessons learned from this. So the first one that I'm going to talk about is remote assist, so augmented reality remote assist. This technology, it's a great communication tool to be there without physically being there. So this is kind of like FaceTime for those of you who have iPhones and that are familiar with that. You basically can see what somebody else sees. So the pictures on the right hand side here, the top one is specific to the HoloLens, or a head mounted display, I should say. And you as the expert who's on the receiving end of that phone call can see what the person sees who is using the head mounted display. And then there's also the handheld devices. So whether it's a phone or a tablet, here on the bottom two pictures, where again, instead of having your hands free, you now have some sort of tablet that you are showing somebody else basically. And the nice things about these applications is that you can circle things and you can mark up the screen so that you both see it, and those markups retain to the object that you circled. So for example, in that middle picture there is yellow circles around the two black dials, and those are retained on those two black tiles no matter where the user actually moves the tablet or the phone. So these are great things, and we've really actually found an uptick after COVID hit, where physical distancing was critical and travel was really challenging, if not stopped. This was a great way to, again, be there without physically being there. And so we leverage this in a lot of different ways. And one of the big lessons that we've learned around applying this is really that it's not widely enabled. And so what I mean by that is, you still have to download the app, put in a username and a password and put it on your tablet or your phone, that kind of stuff. If you are lucky enough to have a head-mounted display in your organization, it's probably a handful, that you have to go and find and probably sign out. And now with COVID, is it disinfected appropriately and things like that. So there's still some enablers to make this really common practice. And also with the common practice piece of it, it's so easy for people to just sort of yell over, "Hey, Johnny, come on over here. We got to go to the floor and look at this," or picking up a phone and telling someone to come down to the line or travel to meet you in person and to initiate this type of communication. So it's not common practice yet for somebody to pick up the phone and call someone through PTC Chalk, for example, or get their HoloLens and contact someone with a remote assist that way. So those are just some lessons learned around a remote assist. And then similarly, we have a lot of experience with work instructions, augmented work instructions. And this was a stat that we just recently found that I thought was really interesting. So augmented reality based training in enterprise will be a $6 billion industry by 2022. So in basically a year, it's going to be a $6 billion industry. So it's kind of amazing, but this really is a really good use case for this type of technology. And the nice thing about the augmented reality work instructions is that it can be in conjunction with that remote assist. So there can be a functionality to have sort of expert on standby. So if you're wearing a HoloLens, for example, and following your work instructions, you also have the ability to call an expert to ask a question instead of having to call somebody, waiting for them to come down to the workstation, et cetera, et cetera. So it really does create some efficiencies. And some of the lessons that we learned here is, really a proof of concept is key. A good, solid proof of concept is needed to build the solution, to deploy it, to execute it, and then to scale it both effectively and efficiently. There is a learning curve with this technology for the user. Before it was a pen and paper or a binder or a book and a physical person standing next to you as the trainee. And so with this technology, that's taken away. And so just having this new tech for some people can be difficult and challenging, but that's where your proof of concept will really demonstrate the value to the organization and to the team members, or not. I mean, there's other situations too where we found where, it thought it could go and it just can't go. And that's why a proof of concept is key to make sure that you're not investing something that just doesn't make sense and won't work within your organization. And then within that proof of concept, working with the IT team to understand and verify their standards for compliance and data security and all that stuff is really, really critical, again, to a successful execution of this. And also the scalability of this as well. I mean, it's one thing, to deploy it at one workstation in one location, but it's a whole other thing when you're scaling this to a larger group. And then we did learn a lot through integration into a really comprehensive quality management system can be challenging. So, some quality management systems are quote unquote simple. I don't think any are really simple, but the more complex the system is, the more challenging it can be to integrate into. But again, ensuring that somebody from this quality management system is part of that proof of concept is critical as well. And then lastly, we've seen a few of our clients, we explore with them a proof of concept, and then they're sort of like, oh, we can do this in-house, no problem. And then, 6 months to a year later, they come back to us and say, yeah, we never got around to it because, fires were burning. We had to answer fires, or, it took us double the amount of time and we still didn't get anywhere. So this whole idea of, internally developing this stuff versus externally developing this sort of solution, it's a big decision as an organization. But just know, there are external experts who have done this and sort of have a template to make this a lot easier for you so that you don't have to internalize this. So those are some augmented reality solutions. And then the next one I guess I want to talk about too is the next slide is quality assurance. So this sort of, I think, is the future of where augmented reality is going. You heard us talk about machine learning and building a artificial intelligence previously. And this is the future of how we can get there using augmented reality. So our friends here at Third Coast, they developed this quality assurance application where they have this tablet, as you can see in the picture in the top right-hand corner. And what the tablet is doing, or what the experience is doing, is it is overlaying the physical product that's in front of you and overlaying it with the CAD drawings of it. So what the design intent of that product is. And so the tablet is overlaying the two, and the user is then comparing and going, yep, this is good, or no, this is bad. And if it's bad, or if it's good for that matter, it's taking a picture and logging it in date stamping it, and putting the user as well. So it's really great from a quality assurance perspective. But then the next level, or the next stage to this then, is building that artificial intelligence, and you're sort of teaching the machine as you go, in a sense that this feeds the intelligence. And so then the next evolution is the app telling the person, hey, I think this is bad. What do you think? And then the human validates what the app states or assumes. And then the next evolution from there is, now you've really taught the machine how to learn and what is good versus what is bad. And then the next evolution is the human could either be taken out of it, or it really is just that extra validation that yes, this is good, yes, this is bad. So it's one of those things where you're right now validating or checking your quality, but then at the same time, you're teaching the machine today that's going to build the artificial intelligence for the future. Kind of a really cool take on augmented reality and where the future is going. So now if we switch gears to virtual reality, just like with augmented reality and work instructions and training, if you will, virtual reality has the same concept when it comes to training. There's lots of great applications here. A lot of it, does have to do with saving costs and increasing employee engagement to invest in this sort of technology. There's also no production interruption to train someone that's brand new. All of this training is offline, if you will, which again, saves some nice costs there. And some lessons learned here is really the same as the augmented reality lessons learned. The proof of concept is so important to prove out the value, or, to take one specific training application to understand the value, understand the benefit to the organization, and then move forward and either scale to other facilities or just scale to other specific training applications. And then again, just like with anything, if you're going to be training people on product or processes, are those confidential? You know, can you have them on a cloud-based server, or does it need to be on-premises server? Understanding, you know, all the data that you want to use in this experience, is that okay or not okay from a data security perspective as well? And then the next way to leverage virtual reality is around this whole idea of process planning. So when you're up front and you have your design layout of your workstation, you have the design of the product that you want to make, this is a really good way to design the process and the layout live in the virtual space to really, quote unquote, feel what the layout is like and what the process is like, and if there's any way to optimize or make that process a little bit more efficient. This is a collaborative experience, meaning, you know, one person could be immersed in the virtual space and other people can be sort of sitting there looking at a screen of what that person is seeing, or you can have multiple people within the virtual experience as well, which is kind of fun and interesting. And one of the big lessons, though, that we learned around this is that it really needs to be part of the process. So there has to be a dedicated or integrated gateway needed here. And it needs to drive the team to use this, really. You know, we've seen situations where, you know, it's sort of an island where, okay, yeah, we can use this if we want to, but it's not necessarily, yeah, at this gateway, we need to go here and look at this and use this sort of technology. There's also the issue of accessibility. So, you know, right now you have to get into a lab or an arena that under the motion capture cameras to participate in this. And the future of where this is going is a truly collaborative experience with people all over the world that can immerse themselves into the virtual world from their respective locations and all meet in this virtual world kind of thing. And then the next slide, and my last slide, sorry, I know we're a little over time, so I will speed this up. The last point here is on simulation. And believe it or not, this word actually has a few different definitions out there for what simulation is and how that's defined. And I'm specifically referring to the product and process design validation. So the video should play here, I hope. I don't know if there's a snafu there, but there is a video here that showcases the product going through to the process and looking at how that product is built. And there can be a digital human model as well that can be added into that simulation. Some of the lessons that we learned here is that there are many enablers that are needed to get this started and enabled. The two biggest ones are your bill of material and your bill of process. If you don't have your product and you don't have your process, there's really no point to this. And if you don't have those in the virtual or digitized, there's really no point to this. But the big value and another big lesson learned is that you have to, this can be an integrated process, meaning, you know, it's not just the process team that's looking at this or the product team, it's really an integrated team of both product and process, which can also benefit multiple functional teams as well. So it's not just product and process that can benefit here and reap the benefits. It's material handling, it's time studies, it's quality, it's ergonomics, it's safety. It's multiple people who could be integrated and could benefit from this type of technology. Thanks, Ree.
Thank you so much, Pam. And that wraps up our panel of experts for today. Should you have any follow-up questions for anyone, take a look. We do have their email addresses listed on the slide. And both Tim from Visual Decisions and I will be posting the recorded version of the webinar on our website. So look for that in the next couple of days. I thank you again for joining us and have a great day.